A little bit about Azim Premji University. Azim Premji University has been running for about 14 years. It is part of Azim Premji Foundation and works, the foundation itself works in specific areas of interest to India: public health, education, development, climate change and sustainability, and a few other areas in this domain. And we at the university run a lot of initiatives in climate change and sustainability because that's one of the focus areas. The 4 pillars of the university are a just, equitable, sustainable, and humane society. And sustainability being one of our 4 pillars, we have a school of climate change and sustainability as well. I would encourage you to check out the website, those of you who might be interested in multiple things. We have, of course, at the university, a number of programs, but specifically in the climate change and sustainability front, we have a major, an undergraduate major in environmental science and sustainability. Many of our students are here. We are launching next year a master's program, a 1-year targeted master's program in climate change and sustainability. We run a lot of short courses for working professionals, from journalists to understand climate data management, all the way to writing nature books for children. And so if you're interested in writing nature books, we have a nature writing for children course. We run a very large climate festival, and you're all most welcome, November 11th to 22nd to the Azim Premji University campus. This year's theme is Mountains of Life. It's a celebration of nature in all its facets. It's an immersive festival which involves movies and performances and street theater and workshops and a lot of data in a very interesting form. We will also have a college quiz competition at the end of October on climate change and sustainability at the Sacred Hearts School. And we will have a metro in the MG Road Metro. We have an exhibition on rivers and forests of life, which is also going to be at the end of October. So if you would look at our website and log in there, you can find all of these details. So please do that. And now to the reason why we're here, because I don't want to take too much time on the university, introducing the university. We've had this Let's Talk Climate Change series for a while, where we get very distinguished speakers who've done a lot of work on climate change and sustainability issues, very relevant to India, to come in and give these lectures. And they're co-hosted finally the lectures are also up on the Bangalore International Center YouTube website, as well as the Azim Premji University YouTube website. For me, it's a specific personal pleasure to invite Professor P.G. Diwakar, who worked on one of the earliest users of digital remote sensing in India, and also at a time when India was setting up the National Natural Resource Monitoring Center, NNRMS. How many of you have heard of it? It's a really unique initiative. Yes, I can see 1 or 2 hands, which was looking at how do you map all of India's natural resources and put them together on one platform using satellite remote sensing so that India's development could be managed as sustainable development. And Professor Diwakar was one of the leaders in this area. And I say of personal significance for me because when I started my PhD in 1993 at the Indian Institute of Science, my professor Badhav Gadgil and I went to meet Professor Diwakar at the Regional Remote Sensing Service Center. And he's the man who taught me remote sensing. At that time, there were very few people in the country doing it. And after that, he's gone on to hold multiple positions in different parts of ISRO, retiring eventually as the scientific secretary of ISRO, and then moving to the National Institute of Advanced Studies as the ISRO chair professor. He continues to work on how you can use remote sensing to plan better development of India. And this is what he's going to talk to us today. So without much further ado, welcome Professor Diwakar.
Thank you, Dr. Harini, and thanks for getting me here, and very good evening to all of you. Very interesting subject. This is one particular subject which possibly I have been working for the last 3 decades. And I feel like working for many, many more years because there is no end for innovation in this particular field. Any amount of work you do with respect to sustainable development, the challenges are continuous. So when we are talking about challenges, let us take this particular subject and look at the kind of challenges what possibly we'll be looking at when we get along. I have a set of slides which will possibly take you through varieties of problems, and many of them solvable problems which we are already able to address it from the government's point of view. We are talking about 3 important problems. One is the global warming, earth warming, what you will call. Acidic oceans is yet another issue. Then we are also looking at rising of the sea levels, another big threat. So there is a need for us to look at these 3 major areas of climate-related impacts, what kind of an assessment and remedial action is possible? That's what we are trying to look at. So there are a set of other parameters which can be possibly seen from space and analyzed from space. For example, the groundwater, the glacier, minerals, fossil fuel, biodiversity, all these are the parameters that can be addressed from space. It could be analyzed pretty accurately, and you will be able to come out with quantitative results in each of these. And these are the areas in which ISRO has been contributing in a big way and working with the respective ministries of Government of India and trying to provide the best part of data that is possible from our own perspective. Ultimately, when we are looking at the humanity, what can we do from space? That's the main topic which I am talking about, but I will break down that into different other areas when I get along. Socioeconomic security becomes very important, but if you are really looking at socioeconomic security, it depends on many parameters or many factors like water security, food security, shelter, health, infrastructure, information security, energy. These are some of the facets which are pretty prominent and important, which we normally look at. There are many more, but I thought we can look at these few important elements. When we look at the socio-economic security through the various indicators like what I have indicated here, it is necessary for us to see how we can use the geospatial technology in the form of governance. For example, at the topmost level is if it is possible for us to use geospatial technology, bring it down to the locals in the form of governance. Is it going to help us? Is it going to solve the problem? Is it possible that we can use the space technology and geospatial technology also for disaster risk reduction? We are seeing the kind of disasters that is happening in our country, the kind of frequency of disasters, the type of disasters that is increasing is quite phenomenal. Possibly, we will be able to address the sustainable development if we are able to look at these parameters and use the right type of technology at the right time. So how do we start? So we start with the two important components of this particular slide. One is the Earth, which is not static. It is rotating on its axis. And the satellites, which are polar in nature, they are polar orbiting satellites. What you're seeing there, they are also orbiting from pole to pole. So what's happening here is you are able to get global data over the Earth from these polar orbiting satellites. For example, each one of these satellites, what you're seeing there, goes through about 14 revolutions around the Earth every day. So it is possible for us to ensure that the local time imaging capability can be established so that every day, 10:30 in the morning, it is possible for you to view a particular part of the Earth, and you can keep doing it for years and years to come. So when you do that, the amount of data that you acquire will be quite enormous, and the kind of processing which you need to do is even more enormous. So this is what ISRO has been doing. ISRO has a massive data center which hosts petabytes of data, not terabytes, petabytes of data of the Earth as well as India, and we use them for varieties of processing. And today I will be taking you through a set of processes that has given us results, and there are many more things to be done, which possibly I will not be able to share today with you. I have picked up a few slides. In fact, when I started organizing this particular slide stack, it was going more than 100. I cut it down drastically because I have to keep time. So I will try to go as fast as possible so that I don't overshoot on the time. So when we look at the space technology for humanity, particularly to ensure the socio-economic security, we normally look at important elements like water security, food security, energy security. These three things are very important. And of course, we need to be looking continuously at the natural resources. And when we are looking at natural resources, we do address some of the important problems or impediments that come in our way, like it could be in the form of drought, it could be in the form of desertification, it could be in the form of wastelands, it could be in the form of land degradation. These are all some typical indicators which create problem from time to time when we are assessing the natural resource or productivity of the country. So this becomes very, very important. The other source for us is the potential fishing zone, which I'll be talking about a bit later. This is another source of food for us. So agriculture and ocean or even inland fisheries provides that kind of elements which helps us in reaching out to our food requirements. Energy, of course, there is a lot of research going on the energy, the sustainable energy. We will be talking about it a bit later. And at the same time, we also keep a close watch on what's happening with respect to the rainfall, the runoff, the snow melt dynamics, and many other issues related to soil moisture, solar irradiance, and things like that. So we are able to watch some of these parameters from space through different set of indicators and through different set of imaging capabilities. The other set of parameters which are also equally important from the climate point of view is the infrastructure, the information security, shelter, sustainable development, the health, and also the governance. If you closely match each one of these securities with respect to the government programs today, last 10 years, I would say, they match pretty well with respect to each ministry, what they are supposed to be delivering. For example, the Ministry of Urban Development used to more talk about structured planning or things like that, but today they are talking about housing for all. So they never used to speak about housing for all kind of programs. Similarly, if you look at the Rural Development Ministry, they look at the road infrastructure also, the rural road infrastructure in a big way, and many other aspects. So each one of the ministry is slightly reoriented with respect to the kind of requirements that is necessary for ultimately the sustainable goals of the country. In addition to these, it is very important for us to have an eye on the disaster risk reduction, DRR, which is popularly called by UN. In fact, I work with UN in a big way on the sustainable development with respect to the SDGs for the Asia-Pacific region. So I will address that at the end. So they UN uses some of the references of what is happening in India so that the other 58 countries in the Asia-Pacific region can emulate similar kind of activities. For example, disaster preparedness, early warning system, response and recovery. These are another set of important areas, particularly disasters and disaster risk reduction becomes equally important. So what we have addressed in these last 3 slides is a set of securities which we need to look at: food, water, energy, and many others, plus the kind of preparedness to see that we are able to go towards resilience towards disasters or disaster risk reduction. So how are we prepared for these kind of issues or these kind of problems, and how do we address them? Indian space program is perfectly made for such kind of activities. Even though ISRO took its birth in 60s, the real applications started off sometime after 1988. Ever since that time, we have very clear focus with respect to what we want to do from the space data. So application, in fact, developmental application or space application drives the entire ISRO program. So all the space infrastructure in terms of launch vehicles, in terms of satellites, in terms of the infrastructure that what we have prepared both in space and ground, all of that is driven by the application needs of the country. Similarly, the kind of capacity building what we address. When we talk about capacity building in ISRO, it is not that we build capacity amongst people, that is one part. We build our own capacity on a regular basis. That means we should be acquiring more knowledge, we should be self-dependent, and we should be able to develop our own systems, and we should have our own labs that are capable of developing any type of subsystem that is required for you to use in space. Space transportation system is yet another very important area where we have been able to do many things on our own, like we have operational PSLV and JSLV, and today we have SSLV also. The 3 types of launch vehicles that addresses all our requirements. In fact, on each one of these, I'll be able to speak at length, but today I'm not going to do that. I will try to go towards the other areas, like what do we mean by sustainable development. I am going to focus more on that. Of course, ISRO focuses on space exploration, space science, planetary exploration, and Gaganyaan is going to be one of the important goals which we are going to see. And of course, Gaganyaan also can give raise to the possibility of looking at Earth at a close range from 400 kilometers, and we should be able to do a lot of research from the kind of data that we get from that particular platform. Now, we have had wide varieties of satellites. One of the important series of satellites that we have been using is the meteorological satellites. We today have INSAT 3D and 3DR, which provides almost every 15 minutes imaging from space, so that we are literally able to look at all the necessary weather parameters on a near real-time basis. But otherwise, we started off with INSAT 1 series, then moved into INSAT 2 series, and finally we are in the INSAT 3 series. We are in the edge of getting into a fourth generation of INSAT-related systems. On the Earth resources management, I'm not spending much time on these because it takes a lot of time to explain each of the satellites, because each one of these satellites, what we have launched from our own soil, has very, very unique capabilities, and quite a few of these satellites are able to provide very unique data sets, which helps us in organizing and accumulating the kind of data which possibly we wouldn't have dreamt of. Particularly, one particular satellite, that is ResourceSat, which has 3 different types of sensors on a common platform. On a single platform, you can look at a 5-meter resolution, you can look at a 23-meter resolution, you can look at a 55-meter resolution. And the 55-meter resolution data provides entire India in every 5 days. That means literally every 5 days, I get a satellite image that tells me about what's happening to my natural resources. This is something very, very unique. And because of such capability, it's called as large swath imaging. This 740 kilometer large swath imaging has helped India to understand at a very small frequency on the natural resources of the country. And this has attracted the attention of the world, wherein at a given point of time, the Agriculture Department of USDA, used to specifically ask for the ResourceSat imaging, including the monitoring of Amazon forest in Brazil. So today, we have the ResourceSat series of satellites, particularly ResourceSat 2 and 2A provides us excellent data. We have a series of generation of Cartosat imaging capabilities. Cartosat 1 that could provide 3-dimensional imaging from space, wherein you can generate digital elevation models, which is very, very important for you to understand the drainage system. You want to understand the slope, gradient, and things like that of a given soil area. It would be most appropriate to use Cartosat 1 type of stereo imaging system. Of course, we have gone down to something like 60 centimeter imaging in Cartosat 2 and 3 series. So we have varieties of interesting imaging capability, and we have a secluded satellite, OceanSat, which looks at ocean and provides ocean productivity related parameters. And we have through the cloud imaging, that is ReSat, which is basically a radar imaging satellite, which provides us very unique data sets. So typically, to take a look at the imaging itself, you can see the kind of data, the quality of data, 2-dimensional, 3-dimensional, or any type of imaging that is required from multispectral or from radar or from different other platforms and capabilities. We are able to do that very, very smoothly today. And in addition to that, the processing of the data so that you can remove the atmospheric problems, because atmosphere, the aerosol, the presence of heavy aerosols, particularly in places like Delhi, does provide a lot of problem for us when we start processing the image data. So we are able to develop algorithms which helps us in atmospheric correction. And of course, understanding the ocean, particularly with the SCATSat, the scatterometer provides us an excellent data for us to understand especially the cyclogenesis, the origin of cyclone and the tracking of cyclone happens pretty easily because we have the SCATSat kind of a system with us. We have also gone into the hyperspectral imaging capability, wherein we are able to talk about 300 sensors data in narrowband spectra, which provides us excellent information, particularly when you are starting to look at soil, agriculture, geology, and various other things. Arctic and Antarctica is very, very important. There is a specific group in ISRO which works on cryosphere. So we look at the North Pole as well as the South Pole, and we keep a very close watch on what's happening to the ice reserves. This is very, very important from the climate point of view. And if we are talking about the rise in the ocean, possibly one of the reasons could be here, and possibly also the Himalayan glaciers. This is the typical example of a digital elevation model that helps us generate elevation data on the ground. We have created elevation data for the entire country. Anybody can download a 30-meter digital elevation model from our websites and use it for various gradient-related aspects. Now, coming to the climate change related studies, I just want to highlight three things. One is that mapping indicators for climate change becomes very important. What are the indicators? It could be glacier, it could be the polar ice. Just now we saw those images. It could be timberline, which is again a very important area. Coral reefs, the desertification studies. These are some typical indicators for the climate change, which we normally measure from space. Monitoring the agents of climate change. This is yet another important parameter where we look at CO2, CH4, etc., SOx and NOx and SOx. The biomass burning, which again is another major problem which we see, forest fires, aerosols. These are the kind of parameters which helps us in understanding some of the typical agents which could be creating problem for us with respect to the climate. On the other side, it is going to be the food security, hydrology, coastal, ocean, sea level, deforestation, and a couple of other parameters. But today my focus will be on these set of parameters, wherein it is possible for us to directly get images of these, measure the inputs, measure the indicators pretty accurately, and quantify them, and sort of get an idea of where we are heading. So this is an important information which helps us in not only understanding where we are heading, at the same time, what is the impact that we are experiencing already with the climate change. Now coming to food security, I'll just take a few of those parameters and I'll try to explain to you how we are doing it and how we are providing this data to the respective ministries, and the government is already aware of some of these parameters that we are able to derive and provide to the government. So when we are looking at the cropping system in the country, it is necessary for not only the entire agricultural system, but also an individual farmer to understand what is agro-met product means. That means what is agrometeorology becomes very, very important, because every crop has its own cycle, right from transplantation until the ending stages where you make the harvest. Senescence, what we call. So we do have a standard toolkit which allows us to operationalize the agromet parameters, and it happens particularly in Kharif, because Kharif is the most important period where the agricultural activity is maximum in the country. So it is important for us to provide the agromet conditions and also the important parameter of soil moisture availability. We have a set of parameters that is regularly derived from INSAT system and being provided to the government. In the agriculture, there was an important requirement from the government. We were just discussing about it. I was discussing with Harini on this. The government was always looking for major crops information of acreage and production, so that are we in the food security zone or are we in a difficult zone. So every season rather, if we are able to get the total production of wheat, total production of rice, total production of oil seeds, total production of possibly sorghum, and many other important crops. There are about 9 important crops, which you can see the list here. So if we are able to provide the acreage and production 1 month before the harvest, the government will be able to take a decision on sufficiency of the food grain for the country. If it is sufficient, or have we overgrown, if we have got more than what is required, the government can plan for exports. If there is deficiency, if we are deficient in the production, government can plan for imports. So the import-export of food grain to address the food security gets addressed with this system. We have gone through a long process. We took almost 3 decades to develop a system which is operational, and it provides us something like more than 90% accuracy. And today, in the government of India at Delhi, we have set up Mahalnabis National Crop Forecast Center. This particular center is equipped with our technology. From 2012 onwards, it provides the government advanced crop forecast information using ISRO's technology, and, and they are able to use it for varieties of decision-making purposes, which helps us to ensure that India takes care of food security in a big way. So this is an important operational mechanism that has been established in the government. This possibly is one of the first, I would say. Parallelly, we also looked at the horticultural crops, like all the fruits and vegetables, and we have made an assessment of the entire country's horticultural crops through a mission. And this particular mission on horticulture gave an idea of what kind of horticultural crops, major crops, how they are harvested, what is their crop cycle, when should be the country ready for what kind of horticultural crop. So this kind of a database, a one-time assessment has been provided, but the additional data or additional information that is required on a regular basis is being addressed by the MNCFC itself, because the capacity building is also done for that particular group. The other source of food is the technology that helps us in getting us the exact fish catch. The fishermen, when they get into the sea, earlier, before this particular tool was brought into the play, they used to really spend a lot of diesel on their boats and run around in the sea, and they used to come back with very little or very meager fish catch. Here is a very interesting information that we have used from space. One is the sea surface temperature, other one is the chlorophyll. The presence of a particular type of temperature regime and the chlorophyll ensures the presence of fish in that particular region. So this correlation has helped us in getting the zones where the fish catch could be there, and the fishermen are provided with this data exactly where to go for the school of fish. And the fish catch has increased, and fishermen are assured of good fish catch, and they're able to come back with pretty good kind of a fish catch. And obviously the livelihood is met of all the fishermen along the coast. We have a huge coastal area. Entire coast uses this particular data for fish catch, and at the same time the food security is met from the fish availability point of view. Of course, recently we have used the GNSS and mobile app to even provide those trawlers that go deep into the sea. For example, if you cross about 10 kilometers into the sea, you are not able to get any SIM, or any particular mobile will not be operational. But our GNSS is 24/7 available, and it spreads across 1,500 kilometers into the sea. So even if you are 100 kilometers away from the coast, you are able to get the signal. And from one of the Ministry of Earth Sciences office that is in Hyderabad, we are able to push continuous information about the fish catch, continuous information about the onset of a disaster in case there is a heavy cyclone that is coming in. Because some of these trawlers, when they get into the sea, they don't come back for weeks. They will go prepared to do maximum fishing and come back. But in case there is a disaster, in case there is a change in weather conditions, we provide all that data through a simple GNSS device. It reaches their mobile, and they are able to go to the safer places. So we take care of the fishermen through this kind of technology. At the same time, we ensure good fish catch for these fishermen who are pretty poor normally, but they come back with good catch. Yet another important area of food security is rain-fed farming. Rain-fed agriculture is predominant in our country because majority of our areas fall under the dry land conditions. Dry land conditions don't have good water resources. Their soil may be good, may not be good, but water is always an issue. So if we are able to adopt ourselves to the watershed development related aspects, then there is a big change that is possible. So there was an interesting project launched in Sujala. I was the lead from ISRO to bring in technology for this. So normally we used to do watershed development not so scientifically earlier, but now with the availability of digital elevation models, we are able to exactly look at the ridges and valleys very accurately from space data, and you are able to address the bunding activity, the water retention activity on the ground, like check dams, nala bunds. It could be various other means by which the ground implements can be done, and you can make a transformation in a particular watershed. In fact, we did this particular project, Sujala, so successfully that there was a drastic improvement in the crop availability, crop diversity, and also the kind of healthy living the villagers were able to experience over a period of time. So we used varieties of satellite data for planning, for monitoring, and also for impact assessment. A very dry area. This is a pre-treatment image, what you see. This is very close to Kolar. This is an example from Kolar. But after the implementation and the kind of changes that took place, you are able to see a dramatic change. The red is vegetation here. It's a false color composite. So in false color composite, normally scientists use false color composites, but normally when we take images to a politician, we don't take false color composite because they think red is fire. So we normally don't show it, but I assume that a lot of scientific thinking people are here, so I'm just showing this false color composite. The red is showing you the different intensity of the photosynthetic activity that is going on in the plants. That's what gets reflected here, and it's pretty sensitive because we use the infrared image as well as the visible part of the spectrum. It gives us unique idea of how the productivity is changing from a degraded land to a productive land. This kind of changes are possible if you respect the slopes and if you respect the kind of cropping you need to do in different slopes, and how do you conserve the soil and water. These are the steps which we taught to the villagers, and 788 watersheds in 5 districts were developed on these lines. This gave a big success for Karnataka, and Karnataka became a leader to start telling about this, and this was a World Bank aided project. World Bank started talking about this project world over. Finally, the government of India thought we should do it for the country. Today I am doing it for the entire country. The soil and water conservation using watershed. In fact, we are developing 86,000 watersheds in the country, use the same technology, wherein you respect the slopes, you respect the gradients, and you do the soil and water conservation for varieties of agriculture and cropping related activities. And we are able to track the before and after changes, both using satellite data as well as GPS aided mobile systems on the ground. So in fact, we have been able to geotag more than 9 lakh field assets. I think the number of lakhs are growing by the day. In fact, I'm not able to track it because that many number of excellent assets are being created. Looking at the success of this, the government also wanted us to see whether MNREGA can also be tracked using space data. So MNREGA also creates a lot of assets on the ground. The rural assets in the country are being created either by MNREGA or by Watershed Development Program. And here we have been able to track more than 3 crore assets. Earlier days when MNREGA was being talked about, people used to say money is being spent, where it is being spent. I'm not able to see where it is. This used to be the kind of discussion. But today, the entire data of where the money is spent is available on our Bhuvan Geo portal, where we literally geotag every asset that is created on the field and the money spent for creating that kind of an asset, and how much amount of employment has been created due to the creation of those assets. So this is a typical way in which we are addressing the food security in this particular area. Getting into the water security, on the same lines, we have been able to create something called as India Water Resources Information System, which talks about basin level, sub-basin level, watershed level, sub-watershed level, micro-watershed level database. This is a stack of multiple layers of GIS that is available at the national level. CWC, that is Central Water Commission, literally uses this particular data for all types of water management system in the country. And looking at that, even Telangana government had asked for a similar kind of a system which could be built, and we have done it. But they are basically looking at major and minor irrigation tanks, and the productivity coming out from the major and minor irrigation tanks are being addressed in Telangana. On the groundwater, see, when we look at water, we need to look at the groundwater as well as surface water. On the surface water front, we have Water Resources Information System. On the groundwater front, for Ministry of Rural Development, we have done the groundwater mapping of the entire country. And not only that, every groundwater potential area also has what kind of recharge structure is required, because exploiting water is one, but replenishing the water is another. So we have been able to create a database which, in fact, there is a Bhuvan Bhujal available in Bhuvan. People can just log in, you will get these maps. These maps will tell you in a given area how to exploit, where to exploit the water. At the same time, how do you do replenishment of water by making recharge structures. So Bhuvan Bhujal is the portal where we have hosted the entire groundwater database. Not only the groundwater database, it gives you a lot of information about the yield range, the depth range, and it also gives you the quality, the water quality, which is also very, very important. So when we talk about water security, we need to be looking at how you conserve the water, how you restore the water, which we discussed in the previous slide. And in this particular slide, I am talking about how you utilize the groundwater and how you replenish the groundwater. Of course, we are trying to extend it to higher scales of mapping wherever there are crises. For example, we have seen the kind of crisis that has happened in 2017, especially Tamil Nadu literally started hunting for water because everything dried off in Tamil Nadu, and that is the time these maps were effectively utilized for providing the drinking water, which is very, very important basic need for anybody. So this kind of a database is helping the different governments, because every government, every PHC is provided with these maps, and at the same time, the database is hosted on online system. On the water security, it is also necessary for us to see that we have a regular assessment of the kind of water. For example, water budgeting becomes very, very important. And we also have an interesting information system that has been produced on Bhuvan and made available. Like, for example, on a weekly basis, it is possible for you to see the map of surface water bodies in the entire country. This is an automatic cycle of imaging that we have done, so that you can just log into the system, go to any part of the area, you will be able to see which tanks are dry, which tanks do have some water at that point of time. So we have created something called as water body information system, which is a running cycle, and it gives you continuous information about the water body. We have been doing water assessments. See, for water security in the country, it is also necessary for us to understand the major basins, what is the water budget, how much amount of rainfall has happened, how much amount of evapotranspiration has happened, how much amount of water has infiltrated, what is left on the surface. It is something called as water budgeting. And this is very, very important for the country to understand what is the amount of water I can use for drinking, how much amount of water I can use it for agricultural purposes, and various other needs. So this is regularly done by the government, so that they have a recent assessment done, and they will be able to take decisions with respect to water. So what we have been doing is, for the requirement of Jal Shakti Ministry, we continuously do these computations through a model, and we provide the assessment for the entire country, taking all the major basins of the country. And these kind of data sets, in fact, the reports are available online, which can be used by many of the researchers who are looking at the water security. Snow and glaciers is yet another important area. We have a massive database created over a period of time, an entire Himalayan range region. We continuously address the snow melt runoff as well as the glaciers, and particularly the information about the receding glaciers. We get that information on a continuous basis, because you are able to use the satellite data with multi-time imaging capabilities. On the energy security, one of the important areas where ISRO has been contributing in a big way is the solar insolation. If you are able to calculate the solar insolation, we can suggest how much amount of rooftop solar energy can be exploited. So we have come out with a solar calculator, which can be run on a mobile, and anybody can make an assessment. You can just download this particular mobile app from our Space Application Center website, and you will be able to literally use it. In a given year, if I put solar panels on the top of my house, how much amount of energy exploitation can I do in my area can be assessed using this tool. because we have the assessment for the entire country. In fact, this has attracted the attention of many global energy security ministries. So we have been able to provide this kind of a system for Africa and many other countries also. We are also looking at the wind energy and wave energy. We have tools that allows you to compute the wind and wave energy in addition to the solar energy. So this is another important set of tool that is being provided from ISRO side. In fact, we have had a long discussion with Niti Aayog, wherein Niti Aayog was looking at energy budget of the country, both from conventional as well as non-conventional sources. And we have been able to help them in assessing the entire country's energy requirement. It's something like demand versus supply kind of an analysis, wherein we are able to also budget how much amount of energy we are able to generate from non-conventional source as well as conventional sources. And of course, today we are looking at a lot of technologies as well as energy is concerned. So we have a good idea of how do we address energy in our country. The next one is on shelter. Shelter is another important thing, particularly the vulnerable areas where you have incessant floods like Assam, Orissa. Some of these places get hit by cyclone quite often. And shelter is a big problem because many people lose their homes in no time. So we have an assessment of, government used to know what is really happening after a cyclone hits a place, or there is a major flood. For example, Wayanad, we have seen what has happened. You need to have an assessment of that. Many people would give different types of an assessment, but using a synoptic imaging from space, it is possible for us to give accurate information about what is the real disaster impact on the ground. We are able to provide at the national level the kind of flood vulnerability assessment system. And we use this on a regular basis and provide this data to the Home Ministry, which uses it for varieties of activities with respect to the shelter. Means focusing on the requirement of the shelter. Of course, we know that Prime Minister's Awas Yojana is running housing for all. In fact, the kind of system what we have been able to provide to the government has helped us in coming to something like realizing 84 lakhs of houses today in the country for poorer sections of the society. This is an important contribution. The PM's Awas Yojana completely uses the satellite-based system, both from the ground and from the space, to ensure that the money again is spent in the right direction. Because basically this comes to something like governance, at the same time realization of a particular structure on the ground for having spent money for that particular purpose. Even for the infrastructure development in the country, which is also very, very important as part of the SDGs, housing goes through a structured plan, goes through a master plan. All the master plans, as per the new policies of the government, is being right now done using space imaging. The entire planning takes place from the satellite data to the actual realization of the present status of an urban area, and then how these maps can be used for water supply system, sewage system, septage, etc., etc. There are multiple parameters that you need to address, particularly under the Amrut program of the government. We have been able to assist the government for 500 such houses in the last 5 years, and this particular program continues to perform well and continues to provide the kind of information that is required for the government to plan, process, and position, particularly the kind of cities like Indore. We are able to see the absolute utilization of the kind of resources that is being provided. On the infrastructure front, we have also supported the government in a big way in Smart City program. Even though they are not so successful in the country, nevertheless, a lot of data was provided from the government, from our side, up to something like even 50 centimeters and 30 centimeter imaging capabilities. And they were used, particularly Naya Raipur used it very, very uniquely, and they were able to come out with a Smart City program, which is pretty well operational today. Using the satellite data, we have also been able to provide information to the government on the management of the heritage sites in the country. All the 3,800 plus heritage sites in the country, the complete management plans have been derived using satellite data, and a repository is created and given to the Ministry of Culture so that they will be able to utilize it for ensuring that the monuments are protected and the vicinity of that particular area, no other development takes place. This is a very important contribution from space. On the health, particularly when we had COVID, we were right in place there. We were able to have a very close monitoring with respect to the various aspects of COVID, not only the infected people, but also the food-related aspects and various other things. Near real-time solutions were provided. In addition to that, various other support to the government like communicable diseases, vector-borne diseases, related aspects also have been addressed. So health, in a big way, can be addressed from space. Today, we are working with the Health Ministry on National Health Resources Repository Database. On the information security, INSAT provides the weather data, particularly adverse weather conditions. We provide by stacking multiple parameters data, because we have varieties of parameters available on INSAT that provides us a wealth of information that can be made available in the form of predictive measurements that helps the normal human being to address the problems. Of course, Wayanad is a very typical issue where we were not able to really solve the problem of taking people to the safer places, but sometimes in tropical conditions we do have issues. Your predictions may not be absolutely accurate, but it nevertheless gives you the idea of where things are going wrong. So coming to the climate change and sustainable development related aspects, we have literally looked at some of these parameters which I addressed, some of them of course, if not all of them. A couple of others which I would like to just draw your attention is that one particular work which we have done in the Himalayan terrain, which basically addresses the alpine tree line shift and coral bleaching. In fact, coral bleaching is another indicator that happens in the sea, while the alpine tree lines will tell you very clearly as a typical indicator from the vegetation point of view. Both these are possible when you have time series data analyzed over a period of time, and you are able to observe the kind of changes that is taking place with time. Similarly, on the cryosphere front, we have been looking at Arctic and Antarctic. There is a dedicated team that works on the cryosphere. See, basically when we look at climate, we have to look at multiple parameters. I've shown you quite a few parameters, but we cannot leave cryosphere. We cannot leave the glacier, snow and ice. They are very, very important. So we literally track this particular data set with multiple time mapping. You can see these maps. This is the Greenland, what you're seeing, and these are different data sets taken out from Antarctica as well as Arctics using the various sensor capabilities that we have from space. This is a typical example of the polar cryosphere dynamics, which we were able to capture using time series data. When a major block detaches from a given area and gets spread out in the Antarctica region. This was a major news sometime in 2017, and I'm just showing it to you. And this is the time series image, what you are able to see on the bottom left, where you are able to see the kind of dynamics that we are able to see with respect to the changes in the ice circumferences. We have a unique data set that is available. They are basically ECVs, and it is possible for the climate modelers to use these data sets if you want to use it for climate modeling. We call it as NICES. It is called as National Information System for Climate and Environmental Studies. We have wide varieties of parameters that addresses terrestrial, ocean, atmospheric, cryospheric, as well as various model-derived parameters are available that can be used for specific modeling, either at the regional scale or at the global scale by the modelers. So we have 6 terrestrial parameters, 5 ocean parameters, and 2 atmospheric parameters that can be used. Moving to the disaster management, we have been very closely watching India and the kind of disasters that we are facing. We have been seeing a pattern. In 2013, one of the major disasters what we saw was Kedarnath disaster. I'm sure everybody remembers that. It was one of the unforeseen circumstances that we faced in Kedarnath. That was the first day I reported at NRC Hyderabad, and I was the manager for disaster management. I straight away got landed on this problem. Okay, so that was the first time I was facing such a huge disaster, which was totally not expected in Kedarnath, of all places. So we swung into action, and we did a lot of assessment of the data, a lot of data analysis was done, and next few weeks, press people were all around NRSC, literally making plenty of coverages of what we did. I'll show you one or two products of what we did there. But the thing is, from the disaster management support point of view, we address floods, forest fires, cyclone, landslides, agricultural drought, as well as earthquakes. These are the major 6 areas that we do address, and we are able to provide. In fact, we have mastered the art of providing absolutely accurate information on cyclones. We are able to save the lives of hundreds and thousands of people in the coastal area, especially when landfall happens. So we have mastered the art of modeling. It is called as cyclogenesis. The cyclogenesis modeling is helping us to see that we are able to exactly predict the landfall where it happens, and we are able to move away the people to the safer places. Similarly, the floods, the flood predictive modeling, inundation mapping, and the exact loss that is happening on the ground due to inundation, we are able to estimate from the space data. And we are able to use the multiple time thermal information that is available from space 6 or 7 times in a day to give near real-time information about forest fires that occurs on the ground. This is on the tropical cyclone prediction. Possibly all of you might have seen a lot about it. I will not cover much on this, but basically the whole idea here is the scatterometer from the OceanSat, as well as the other satellite data that is available from outside the country, is able to give us accurate tracking of the cyclone ever since its formation until its landfall, so that we are able to track it end to end, and we are able to move people to the safer places. The major advantage of this is we are able to save lives, we are able to save livestock. These two things are very important. Obviously, infrastructure will go for a toss. We have to rebuild, nothing can be done, but human lives, which are very precious, that gets saved. This is the typical example of the kind of snowfall that took place in Kedarnath just a couple of days before the major disaster that took place. You can see the change before and after. Just a couple of days, just in a week, the amount of snowfall that took place in the upper reaches of Himalayas, which directly actually melts into the Kedarnath, could be seen very clearly. And the amount of water that accumulated in the Chorabari glacier was unbelievably very large. This is a typical picture. I don't know, some of you might have seen. This was published in a big way in all newspapers, in all channels, everywhere it was there. This is the Chorabari glacier. This is Kedarnath. It has become a big settlement. Ideally speaking, there is no settlement supposed to be there. Except for the temple, nothing should be there, strictly speaking. But man is always very eager to have so many of his wishes fulfilled, and this is a typical wish fulfilled, which only resulted in a major disaster where thousands of lives were lost. So this is the Chorabari, Tal. We call it as Chorabari Tal. This is the moraine, which is a natural moraine caused due to heavy glaciers. Due to the heavy water inflow, the moraine gave way. When the moraine gave way, the entire gallons of water, I would say thousands of liters of water, just dropped down onto the Kedarnath settlement, and it literally drove away anything that came in the way. And you can see the kind of impact what you can see in this particular image. A new channel was formed. The water just went through that particular channel, and it literally went through every part of the Kedarnath and drove away. In fact, there was a small village. It was completely washed away. There are no houses. There are no people in that village. You can't have anything about it. And there were more than 5,000 landslides at that particular point of time, as you can see here. So this was continuously monitored, and first-hand information was provided to the government, because this was the only way which we could have provided, but sadly we could not prevent this particular disaster. Similarly, the Kerala disaster, which happened a couple of years back, we were online providing a huge amount of data. This was also a sort of man-made disaster, I would say, because all the gates were opened up and entire water gushed down to a huge amount of area where a lot of inhabitants were there, and it caused a major problem. We did see a major urban disaster. In fact, I think a lot of youngsters should start working on urban disasters, because urban disasters are becoming more and more popular, including Bangalore. 2022, we had a very sad problem created. In fact, we know the problem, why. We have been telling the government. But you can see the Tamil Nadu problem here. First of all, it is close to the coast. The water cannot easily run into the sea, because almost the sea level and land is almost plain. You don't have slopes there, no gradients. So you can get into a major problem. So this is a typical example of the data. In fact, the beauty of this particular work, what we did is, this data was real-time being provided to a lot of NGOs, and NGOs were able to guide the people which direction they have to drive, which direction they should not drive because of flooding. And this helped a lot of people to escape from the flood. See, you can find innovative ways in which you can use the satellite data when crisis comes into the picture. And we found an interesting NGO helped people to move out of Chennai at that particular point of time. Accumulation of water that takes place on the backside, this could create a huge problem. If the accumulation is very high, the water, when you release it, it could possibly drown a village very easily. So what we did an estimation of the amount of accumulation of water from space data, because these areas are very difficult to access. In fact, some of the experts had to be taken by the chopper. They had to be dropped down. They did controlled, they had to do controlled firing of small explosives, so that the water channel can be slowly opened out. If you open it out, in fact, this whole thing was happening in Nepal. So we worked with Nepal to see that the water is released slowly, so that our villages are not affected. And we could exactly estimate the amount of debris, and how we have to, what kind of explosives can be used so that this debris can be released. All that could be done using computational techniques on the satellite data. So these are the kind of things which one can do today. This is what I'm talking about forest fires. It is possible for you to have a continuous information with respect to the availability, or sorry, with respect to the onset of fire. This is the smoke image that you are able to see on this side. This is another example of the cyclone. I can skip this. Of course, we are helping the government in governance. Indirectly, the governance also helps in the sustainable development. We are looking at various aspects. It could be livelihood security, housing, it could be watershed, so many other things which we already talked about. I have a few examples here which I'm showing you. So basically, looking at the kind of positive experiences India has, UNSCAP has been working with ISRO very closely. I have been representing ISRO all the time, and we have been addressing many areas of sustainable development goals, and I have been writing a lot of papers on how technology, in addition to the space, can be interfaced together so that you can address them better. For example, by 2030, we are supposed to have implemented the SDGs in all 58 countries. And I think India has done a very good job in all these areas because of the kind of data, the kind of monitoring system, the kind of mechanism that the government has used by interfacing the space system with the respective ministries of the government of India, and we are able to provide a lot of data. And in fact, UNSCAP, looking at our technology, is trying to advise people on accessibility of data, affordability of data, actionable products, and services, and also availability of data at the critical path. So they are looking at a lot of interesting parameters which can be derived out of the space data, and that can be used for the ground, and hence can be addressed particularly from the SDGs point of view. I would like to stop at this point of time.